All right, let's get right into it. Today, we are breaking down the SYB Tech 2026-27 syllabus for a genuinely fascinating course, Measurement and Instrumentation. If you're ready for an academic journey that takes foundational theory and actually bridges it with cutting-edge industry practice, well, you are definitely in the right place. We're going to unpack exactly what you'll be learning, how you're going to be evaluated, and most importantly, why these skills are absolutely critical for your future as a modern engineer. So, I have to ask, are you ready to literally measure the future of engineering? And I mean, that's not just a rhetorical question to sound catchy. This course is meticulously designed to take you from traditional fundamental concepts, like understanding how a physical dial moves on a meter, all the way to the future-ready skills that today's job market is practically begging for. We're taking time-tested engineering principles and looking at them squarely through the lens of tomorrow's technology. Okay, here's our game plan for today. We're going to cover the course goals, the 5-unit plan, AI integration, the tech stack, and finally, the grading scheme. Let's start with Section 1, Course Goals, from remembering to analyzing. A lot of folks think instrumentation is just about memorizing endless facts and formulas. But actually, scratch that. It's really about how you process information. Notice how these 4 course outcomes scale directly up Bloom's taxonomy. We start at the baseline, level 1, simply remembering the working principles of various instruments. Then we step it up to level 2, understanding the construction, explanation, and calibration of those tools. Next is level 3, applying. This is where you actively apply measurement techniques to calculate power, energy, and circuit parameters. And finally, the big one, level 4, analyzing. You'll be expected to critically analyze different measuring methods and transducers for real-world applications. It's just a perfectly designed progression of your cognitive skills. Now, what's really cool here is how this academic theory connects directly to the real world. The syllabus specifically targets the gaps between standard academic outcomes and what the industry actually needs right now. Case in point. In the 3rd week of August, there's a scheduled field visit to Rushab Instrumentation Company. That's where you'll see the real-world societal and environmental impact of professional engineering solutions firsthand. Plus, there's an expert lecture lined up with Miss Nitisha Kumari to give you those industry-oriented basics. The whole shebang is about making you industry-ready from day one. Moving right along to Section 2, the 5-unit plan, which is basically our chronological journey through the semester. This course builds from the ground up, starting on July 6th. Unit 1 kicks off in July with basic measuring instruments and transformers, diving into things like the principles of moving coil and moving iron instruments. Then, as we roll into August with Units 2 and 3, things get a bit more complex. You'll tackle power and energy measurement, including dynamometer-type wattmeters, and then you'll measure resistance, inductance, and capacitance using bridges like Wheatstone, Maxwell, and Sherring. By September, Unit 4 brings us firmly into the digital age with electronic instruments. Think data acquisition, ADCs, DACs, and digital storage oscilloscopes. Finally, in October, Unit 5 brings it all together with cutting-edge intelligent smart sensors. It's a fantastic narrative arc, honestly, taking you from basic moving coils all the way up to smart tech. All right, Section 3, AI integration or measuring with machine learning. This right here is the so what of the entire syllabus. We aren't just learning standard instrumentation. Literally every single unit in this course is supercharged with cutting-edge AI techniques. When you study basic instruments in Unit 1, you're also going to look at ML drift estimation algorithms and error prediction. In Unit 2, power measurement is paired with AI anomaly detection and consumption forecasting for smart grids. Get to Unit 4's electronic instruments and boom, you're introduced to denoising autoencoders. And Unit 5 smart sensors, you'll be looking at sensor fusion, embedded ML models, and predictive maintenance. This integration is exactly what makes this a true 2026 blueprint. It's a real game changer. To pull all of that off, you need the right tools. That brings us to Section 4, our tech stack. Mastering these specific tools is going to make your resume pop for sure. For core software, you'll be utilizing industry heavyweights like MATLAB, Python, LabVIEW, and even Excel. For AI libraries, the syllabus highlights the big 3, TensorFlow, PyTorch, and Keras, alongside scikit-learn. To visualize all that data, you'll leverage Matplotlib and Plotly. And for development platforms, you'll be hands-on in Jupyter Notebooks, Google Colab, and MATLAB Online. You are not just memorizing theory. You're building a massively marketable, highly modern tech stack. Okay, now for the part I know you've all been waiting for. Section 5, the grading scheme and how you'll actually be evaluated. Your 100 total marks are definitely weighted toward the end, but with a great twist. You've got your end-sem exam, which carries 60 marks. Then your in-sem exam sits at 20 marks. But that final slice is what is absolutely crucial. 20 marks are dedicated to Continuous Comprehensive Evaluation, or CCE. That means a whopping 40% of your total grade between the in-sem and the CCE is secured before the final end-sem exam even begins. Let's quickly break down those 20 CCE marks so you know what that continuous effort actually looks like. It's basically a steady climb divided into 4 5-mark chunks. First, you'll tackle Assignment 1 on the first 2 units before the in-sem. Next, Assignment 2 covers Units 3 and 4 before the in-sem. You'll also take a series of LMS tests, and here's the nice part. Only your best 5 scores out of a minimum of 10 tests will actually be counted. Finally, a class test on Units 3, 4, and 5 rounds out the CCE right before the final.
And here is a quick pro tip regarding those LMS tests. The results are declared immediately after you take them. This is purposely designed for rapid learning. By getting instant feedback, you can track your progress in real time, zero in on your weak spots, and adjust your study habits immediately. No more waiting around for weeks to see if you actually understood the material. So I'll leave you with this ultimate question. How will you apply these tools to solve real-world engineering problems? You've got the 5-unit roadmap, the AI integration strategies, and a seriously powerful tech stack. This course is so much more than just an academic hurdle. It's a toolkit waiting to be opened. I hope you're energized and ready to hit the ground running when classes kick off on July 6th. Keep learning, keep analyzing, and I'll catch you in the next explainer.